Everybody, we're back today with like terms, and we're just going to identify like terms. We're not going to combine them, we'll just identify them and kind of put them in groups. So you can see on the screen here I have a ton of terms. They're all different colors, and I just made them different colors so you could distinguish between the terms in case they get jumbled. There's no relation between the colors of the terms. So we have several terms here, and I'm just going to start picking and organizing them by whether or not they are like terms. So I'll take this y squared, and I'm just going to move this over here. Put all the y squareds there. I see right here an x squared. I'm not going to move this x squared to be with the y squared because these are not like terms. And they're not like terms because they have different variables. So I'll move this x squared down below here. Come over here, I see a negative 6y squared. This is a like term with the y squared because they both have y squared. So these two are like terms. We could combine them if we wanted to. Then we have 13xy. Well, this has a y like this one does. Doesn't have an x though. So this is not like terms here because it contains an x. This one down here contains an x, but it does not have a y. So the 13xy is a completely new term. So I'll put that one up in the right-hand corner here. Next one, negative 2x squared. Well, it's obviously not that because it's not a y. Down here, x squared, x squared. These two are like terms because they both have an x squared. Next, negative 4xy squared. Well, like that, and no x. Down here, no y. Ooh, this one has an x and a y, but the difference between these two is that this y is squared, this y is not. So while these two might look like terms, and you might want to say they're like terms because they have an x and a y, they are not because this y is squared, this y is not. So let's make a new group. Let's put it right here. Let's go with 15xy squared. When I say that one, xy squared. Once again, the y is not squared on this term. The y is squared here, just like we were last time. These two are like terms because they both have an x. They both have a y, and both of those y's are being squared. And notice the coefficients, the numbers in front of the variables, really have no meaning on whether or not they're like terms whatsoever. It's all depending upon the variables and the degree of the variable, or the exponent on the variable. Moving along here, we see 9x squared y. 9x squared y, that's got an x and a y, but unlike these two, this x is squared, and here the x is not squared. So this is a whole new term once again. So I'll move this here, and now we're kind of getting a little jumbled, so I'll try to organize these a little bit better. 5y squared. 5y squared. That goes over here because it's a y squared, y squared, y squared. Next, x squared y. X squared y, where is the x squared y's? It does not appear that we have a group of, wait, we do have a group of those. It's right here. There it is. X squared y, x squared y. Let's see, 4x squared. Let's take this one here. 4x squared. No, not that one. Where does the 4x squared go? Yep, right here. There it is. 36x squared y squared. This appears to be a new one. No y squareds there, no x squareds there. Can't be this one because the x is not squared. Can't be this one because the x or the y is not squared. It's not this one down here because the y is not squared, so it looks like we have a new group. New group, 36x squared y squared. Then we have negative 2x squared y squared. That one can go down here with this. And then we have 2xy. 2xy would go here. And now all of these are organized into like terms. And to make those a little bit more clear, I'll kind of separate. Those two are like terms. These two are like terms. These two are like terms. These two, these three, and these three. So the key with like terms is identifying the variable, and then the degree of the variable is the critical piece.